Hi Year 4 and welcome to Tuesday's maths lesson. Now so far in Year 4 we've learnt how to add, we've learnt how to subtract and we've learnt how to multiply. So now we move on logically to the next step. We're going to be dividing today and we're going to be dividing by just a single digit number. So that means numbers only up to 9. But before we start, let's think about the basics. What is division? What are we doing if we're dividing? Well, what we're doing is splitting things up equally. And that could be a shape. So this circle here has been split into equal parts. It might be sharing sweets between friends. So sharing things out equally. Or it might be grouping things. Like here we have groups of 3. All of those things are dividing. I have a chain of 10 multi-link cubes here, but how can I divide them? And remember, if I'm dividing, it has to be equal. Well, one of my options would be to share it into 2 groups. So I've got one group here and one here, and I just share out my 10 one at a time by moving them across. Like we did when we were halving a few weeks ago. Oops, that one goes there. You've got to make sure you share them equally. And does it work? Yes. So what I've done is I've divided my 10 into 2. I've shared it between 2 people and each one has 5. So 10 divided by 2 is 5. We can also show 10 divided by 2 is 5 by breaking the multi-link cubes into groups of 2. So we have 5 groups of 2 here. We use dividing quite a lot with our times tables. If you remember at school when we use our TT Rockstar sheets, one of them every week is full of division questions. So let's have a look at a calculation, see if we can work it out. If we look at this one here, we're starting with 36 and all it's asking us is, if we split things into groups of 9, how many are we going to have? So you need to count in 9s until you get to 36 and then you stop. Pause the video to work out each one of these calculations to see what the answers are. Ready? Okay, so 36 divided by 9. Well, if I count up in 9s, 9, 18, 27, 36. That's 4 lots of 9. There we go. 60 divided by 10. So how many 10s are there in 60? Well, that's an easy one. 6. 24 divided by 3. So if you counted up in 3s, how many 3s were there? There were 8. 56 divided by 8. Now we're kind of new to our 8 times table, but hopefully you've managed it. 56 divided by 8 is 7, because 7 8s are 56. And 54 divided by 6, how many 6s make 54? 9. Well done if you got those. And that's all dividing is. It's splitting something into equal groups. But what if our number is slightly too big for us to work it out easily? Here I have 57 divided by 3. Now we know our 3 times table, but we only go up to 36. This is 57. Okay, we could share out multi-link cubes. That's a lot of cubes. We could be here for a very long time. So how are we going to work it out? Well, actually, there's a really useful thing that you did yesterday that can help us. We can use a part-whole diagram to split our number into pieces. So we have 57 at the top, because that is our total amount that we're starting with. And quite often you would use part-whole diagrams to split into 10s and 1s. So you might expect me to say that we're going to put 50 in one circle and 7 in the other. But does that actually help us? Not if we're dividing by 3, because I don't know how many 3s there are in 50, but I certainly know that I can't divide 7 by 3, not without having any left over. So that's not going to work. But yesterday we looked at different ways of splitting numbers, of partitioning numbers into a part-whole diagram. So there are different ways of doing it. And the most obvious thing that I know is that we are looking at the 3 times table. And what really easy fact in the 3 times table do we know? We know that 30 of those blocks, that's 10 lots of 3. 10 threes are 30. So we've used up 30 of our blocks already. So we can put 30 in this box here. But instead of drawing all the cubes, because that would take a really long time, we just write underneath 10 times 3. So how many cubes have we got left? Whatever we've got left, we need to put into this circle. So if we've used up 30 out of our 57, we've now got 27 cubes left. But instead of, again, drawing all of those cubes, we could just write underneath how many 3s are in 27. Well, 27 is definitely in our 3 times table, so if we count up, we can work it out. Pause the video if you need to. Reckon you know the answer? Okay. It's 9 times 3. 9 3s are 27. So what we've done is we've effectively just broken down our 57 into 2 numbers that are in the 3 times table, because we know 10 3s and we know 9 3s. So what's the answer to our question? Well, how many 3s make 57 is the question. So we know that it's made up of 10 3s and 9 3s. So all we have to do is add all of those groups together. If you've got 10 groups and 9 groups, how many groups have you got? You've got 19 groups. So 57 divided by 3 is 19. This is a great way to break down bigger numbers into the times tables that you know to help you solve division calculations. Let's try another one. 68 divided by 4. Now, if you're super confident, maybe pause the video here and have a go at solving it yourself, and then watch the video through and see if I do the same thing as you. If not, just come along with me. So 68 divided by 4, the first thing we need is our part-whole diagram. And I've put 68 in the top because that's our total. And we're looking at the 4 times table. So the most obvious fact that I know about the 4 times table is 10 4s. 10 4s are 40, and that's smaller than our total number. So I'm going to put 40 in one of my circles. And I know that that's 10 lots of 4, so that gets written underneath. So how many have I got left to put in the other circle? That's right, I've got 28. And how many 4s make 28? Again, pause the video if you need to work it out. By working through my 4 times table, I know that 7 4s are 28, so I've written that underneath. So really what I've got here, 68, is built up of 10 4s and 7 4s. So the 10 and the 7 are the important numbers. I've got 10 lots of 4 and 7 lots of 4. So how many groups have I got in total? I've got 17. So that's my answer. Now pause the video and have a go at these 2 calculations on your own. Are you ready for the answers? Okay, let's have a look. So the first one is 144 divided by 9. Now 144 is bigger than the numbers we were looking at just now, but the method is the same. I put 144 in the top and I'm dividing by 9, and I know that 10 9s are 90, and that fits inside my 144, so I can put it here. Now to work out what's left, if you're not quite sure and you can't do it in your head, you can always do a column subtraction like I have here. So I had 144, I took away the 90, and it showed me that I had 54 left. I've written underneath that 90 is 10 lots of 9 and 54 is 6 lots of 9. And so my 10 lots and my 6 lots go together to make my answer, which is 16. Let's now have a look at this one, 96 divided by 6. Well, same thing again. Put the 96 at the top. I know that 10 6s are 60, so I can put that here, which is 10 6s. and I've got 36 left, which is 6 times 6. So I've got 10 lots and 6 lots, which go together to make 16. So there you go, both calculations had exactly the same answer. But what if it's trickier than that? What if our starting number is too big? So we've got 135 divided by 5 here. And if I try the method that I've just taught you, 135 at the top, and then I know that 10 fives are 50 and I put it there, well, how much have I got left to put in the other arm of our part-whole diagram? If I do a calculation at the side here, 135 take away 50, that leaves us with 85 left. I can put 85 in there, but I don't know how many fives make 85. That's not in our times table. So maybe this isn't the best way of doing it. However, I do know that I can multiply by multiples of 10. I can do more than 10 times 5. So I know that 10 fives are 50. I know that 20 times 5 is just like 2 times 5, but multiplied by 10 with that 0, so it makes 100. 30 times 5 is 150, but that's too many because I've only got 135 here. But that 100, I could put that in one arm of the part-whole diagram. So I can put in 100 there, and underneath I write that that's 20 times 5. Well, that makes it a bit easier. So what have I got left to put in the other arm of my part-whole diagram? I've got 35, and I know through my 5 times table that that's 7 lots of 5. So that just made it a lot easier. Now I can do exactly the same thing as I did before. I've got 20 lots of 5 and I've got 7 lots of 5. So how many lots have I got altogether? I've got 27. So sometimes if just doing 10 lots of your number doesn't work going into your part-whole diagram, have a think about whether you know more than that. You might know 20 times that number, or 30 times, or 40 times even. Have a think about it and use the most sensible number so that you don't end up with an enormous number in the second arm that you still can't divide by 5. For today's challenges, you've got the choice of challenge 1 or challenge 2, and then if you were really confident with challenge 2, then you can go on to the super challenge. Challenge 1 sticks with the kind of dividing we were doing towards the beginning of the lesson. So looking at just 2-digit numbers and using a part-whole diagram that looks like this. So one arm will have 10 times whatever you're dividing by, and then you work out what the other arm has. Challenge 2 is more like the one we did just now, 135 divided by 5. But again, you just need a part-whole diagram that looks like this, but you might need your multiplying by multiples of 10. So you might need 20 lots of something or 30 lots of something. The super challenge today is looking ahead at tomorrow's lesson, but trying to work it out before I tell you anything. So I want you to experiment with the part-whole diagram that I've shown here, the one where we partition into 3 different things. And I want you to work out how that might be useful for solving these sorts of calculations. So these divisions are a lot bigger than the ones we've been looking at today. See if you can work out logically how I would use that part-whole diagram to help me divide those numbers. And then tomorrow you can see if you were right or not by watching the video. Good luck today, work hard, and I will see you again tomorrow.